Hello, welcome to Virus Bootcamp. In this episode, I'm going to explain the difference between bipolar and unipolar LFOs, and then show you how combining the two can create new modulation possibilities for the virus. So I've set up a simple patch here which modulates oscillator 1 pitch via LFO 1, and I've used both versions of it, bipolar and unipolar. At the moment, it's not doing anything because I've left a mount set to 0. But I want to show you the Lfo page here and the graphic of the square wave to help explain what's going on. So if you imagine this central line here as being the original value of the target parameter, then when I start applying modulation, in the first half of the wave is going to increase the value of the parameter, and in the second half of the wave is going to decrease the value. So the effect on the pitch will be, it'll be higher here and lower here. But what you won't hear again is middle C, if I play middle C, that is. So here's middle C, I start applying the modulation, and you'll hear that the pitch will go higher and lower than the original at the same time, basically. And also notice how that if I apply negative modulation, the effect is almost indistinguishable, because really all that changes is the phase of the modulation. Now compare that to unipolar. So what's happening now is that the modulation is only being applied in one direction, away from the target parameter. So, or away from the target value, sorry, the original value. So it's as if this line going across the middle has actually been moved down to the bottom of the wave here, so that the first half goes all the way up like that, but the second half stays where it is. And notice that there's a marked difference between positive modulation and negative modulation. So for those reasons, sometimes unipolar is a very convenient choice when you're designing sounds. And you can apply that to the filter. There's quite a classic effect you can get from that, where I basically just took the patch which I showed you just now, applied it to filter cutoff, and used the mod wheel to increase the depth of the modulation of the unipolar LFO. I'm using a one-pole resonant filter. So very easy to achieve that kind of effect now with unipolar LFOs. I want to show you another patch I've made, which uses a combination of both modes of the same LFO applied to the same parameter. If you're wondering why I've applied it twice here, it's because actually by doing that in the mod matrix you can get an even steeper modulation curve. But really the main effect that you're hearing here is the combination of the unipolar and bipolar LFOs. So I'm using a triangle wave, because this particular technique doesn't work on the square wave, but it works on everything that has a curve or a ramp to it. So explore all of the spectral waves, because there's some pretty cool effects to be heard in there as well. But for now, I'll just stick with the very familiar effect that you can achieve with this when applied to the triangle modulation. And I've assigned the mod wheel here to increase the rate of the LFO. And I've also thrown in another patch which is a little bit sort of more obscure, I guess, but it's if you explore it and can maybe mess around with it, try changing the unipolar LFOs to the bipolar versions and seeing what a difference that makes. And you'll see how by using the unipolar LFO, you can just keep a lot more control over the sound sometimes. So again, I'm using the mod wheel to increase the depth of the modulation. So I hope that gives you some more ideas. I'll see you in the next episode of Bootcamp.